consider the following word problem. Outside temperature over the course of a day can be modeled as a sinusoidal function. Suppose that you know the high temperature for the day is 92 degrees and the low temperature of 78 degrees occurs at 4 a.m. Assuming that T is the number of hours since midnight, find an equation for the temperature D in terms of T. First, what I find to be kind of helpful is to draw a real quick sketch of what it is that's going on. So in this case, what we're doing is we know that we're going back. A sinusoidal function means that we're going to do a nice curvy thing. Sinusoidal functions can either be sines or cosines since they're very related to each other. The next thing that we need to identify here is we need to kind of figure out what's going on. We know that we're bouncing back and forth. The high point up here is at 92 degrees. The low point down here is at the bottom of the curve is at 78 degrees. And so it's just bouncing back and forth, 92 on the high, 78 on the low, 92 on the 5, 78 on the low. The other pieces of information that we have that are kind of important here is that it is varying over the course of a day. And so that's giving you some information about the period. Because it's varying over the course of a day, we would say that a full period is happening every 24 hours. And so that's the next piece of information that we can use, that it's going back and forth. Now, the problem tells us that T is the number of hours since midnight. So if you think in terms of your zero line here on your x-axis, so the time is going to be along here on the bottom. 0 is actually at midnight. So over here at 4 a.m. is when we hit that low temperature. So here, we'll just call this 78 degrees here. We know at 4 a.m. I'm here at this temperature. And then we're going to go up to 92. And we'll just call this 92 up here. So we're going to go up to 92. And then we're going to come back down to the low of 78 like this, and then we'll continue back up again. And since we're varying over the course of a day, the next time that we hit this low point again is going to be at 4 a.m. again. And so this is going to be a full 24 hours would have gone by as we go through here. So if you want to think of this in terms of T, where T is the number of hours since midnight, this is going to be 4 a.m. here. The next 4 a.m. is going to be 24 hours later, so this is going to be at 28, if you kind of want to think of it that way. So we've done a full period. Now, on this case, keep in mind that this is going back and forth forever. Since 78 was the low, it's really not dipping below 78. It's coming back up here, and it's doing this thing, if you want to think of it in terms of that. When you go to try to write your equation, really what I like to do is just kind of focus on that one full period set that I have in order to do our information. If our period is going to be 24 hours, keep in mind that the other pieces of information that we like to identify here are what our amplitude is, our midline, and what our base function comparison set is going to be. Keep in mind that for this one, because I know the low point where I'm starting and when that's starting and how that's a full period, I would tend to say that my base comparison function, I'm going to use the negative cosine because I'm starting at a minimum value. The next piece of information that I think is really useful here is the fact that notice that our low point is not starting at time 0, it's starting at time 4. So it's also important to note here that I need to shift my traditional inverse or negative cosine function. I need to shift it 4 to the right so that I can get my my base comparison here. So I'm actually going to have a left-right shift in this particular problem. I do also have my period here is 24 hours. Keep in mind that when we go to write our equation out, that we don't actually put the number that's the period in my formula. We use b equals 2 pi divided by my period. So it's going to be 2 pi over 24 or pi over 12 that I can write into my function when I go to do that. Now, that gives me my b value. I've got my comparison here and some shifts that I'm going to need to worry about. Now I need to identify the amplitude and the midline. This one's a little bit strange. They don't actually give us the midline, but they do give us a high point and a low point. The midline should be exactly halfway in between there. So you can do your nice little figurings, or if you're having trouble balancing it out, keep in mind that you can just average what those two values are. So we can do 92 plus 78, which is going to give me, what is that, 170, and then I can average those two values and get 85 should be exactly in the middle, and that would be, therefore, my midline is going to be at 85 degrees. The amplitude is the distance from my midline up to the top. So from 85 degrees to get up to 92, that's 7 degrees up from the midline. It's also kind of nice to do a little double check. If it's 85, it should be 7 down to the minimum. And so if you do 85 minus 7, we do in fact get 78. So I've identified my period, my amplitude, my midline. I've got my base comparison graph, and now I should be able to write an equation for the temperature. So my temperature D in terms of T, and I can just use this function. So it's negative, I put the amplitude out in front of my function, so negative 7 cosine. On the inside, I have to have my B value that reflects my period change, so that's pi over 12 times T. However, I've got a right shift, so I need to take into account my shifts. Our left and right shifts are inside functions. Since I'm shifting to the right, I'm going to use minus, so it's going to be T minus 4, and that gives us that. And then we always need to add what our midline is, so in this case, it's going to be plus 85. And so from that word problem situation, kind of recreating the picture here and doing a little bit of reasoning and then coming in and identifying, again, these 4 big key features. What type of graph are you doing, sine or cosine, positive or negative? What's the period, what's the amplitude, what's the midline based on the information that they give us. And we can do a little bit of reasoning to figure those out. And you have an equation, which you can then use for whatever you need.